Parev, imanuna bus Momjian, nirochun angaren BDSM. Someday I'll be able to do this in Armenian. I will keep trying. It is wonderful to be here back in Armenia. This is my 5th time in the country. I am here on a medical mission trip. We had last week we served 460 patients in Gyumri and Vanadzor. This week, starting on Saturday, I was in Goris and Sisyan, visiting some of the churches there. And again, wonderful to be here. This is the first of hopefully many user group meetings. We'd love to have more conferences also come to Armenia. I know that that's been a goal for many years. My first trip to Armenia was in 2004, actually funded by the United States government to help build the software industry in Armenia, particularly because obviously there's an incredible mental capability and scientific capability of the Armenian people. And it is an excellent opportunity to help build software industries in the country. Obviously, that was 20 years ago. Software industry in Armenia has expanded greatly since then. Although I know there have been some ups and downs in the past couple of years. People have explained that to me. What I would like to talk about today are two things. One is the software that I work on, which I'll talk to you in a minute about, called Postgres. I've been working on that for 28 years. And secondly, second half, I'd like to talk about open source in general and the software industry in general. Because I know many of you are trying to figure out what career opportunities are available, what is open source, how can I get involved? Is that something that I personally can be a part of and allow it to become my career? When I started 28 years ago, open source wasn't really a career possibility, but now it is. So again, I'd like to talk about those two things. I'd like to take questions. In fact, the second half hour, I would like to speak for a half hour about Postgres and a half hour about general open source, if that's acceptable. And I'd like to take questions as we go. In fact, the second part, I'd like to take the majority of questions from the audience, because you must have questions for me. I've been in the industry for a long time. I've seen a lot, and I can sort of help guide people or talk about what the opportunities are. Again, I know that I think even back 20 years ago when I was here to help grow the the open source industry, I think open source is a unique opportunity for Armenia to thrive. And again, when I get to that segment in about half an hour, I'll be glad to talk about that. So let me ask, are there any questions before we get started? My wife Christine is in the corner. Hello. There she is. And my cousin Vartan right next to me. There you go. Am I missing anything, Christine, that I didn't mention? We're very glad to be here. Yes, always love coming here. We're staying at the Armenian Missionary Association, which is on Bagramian Street. They built some apartments for people, so we're having a wonderful time. And of course, that organization is responsible for taking funds from Armenians around the world, bringing them to Armenia, and then allowing them to thrive. For example, they're working a lot with Artsakh people who have come to Yerevan. They're working with Davidisian School, where we were this morning. So a lot of great stuff going on. Okay. So again, I'd like to start talking about Postgres. How many people know what Postgres is? Okay, good. Okay, some people aren't sure. That's fine. That's fine. So basically, how do I explain this? So historically, back in the 90s when I was an application developer, I used to write applications for law firms. So I was a consultant, as many of you probably are now. And I would use proprietary databases. So databases normally produced in the United States, Oracle, DB2, Microsoft. At that point, Sybase was big, Informix was big, Ingress was big. And those names may mean nothing to you now, but in the 90s, they meant a lot. And I was always a type of person that was curious. I'm always asking questions. And I was always curious. My wife is laughing. And I was always curious, how does a database work, right? So I was using a database as a user, but how does it know how to understand a request and optimize it and so forth? So I got involved with Postgres because I was curious about reading the source code to a relational database. Really started as just a hobby. I was bored. I had been, how many people are bored at work? I certainly was at that time, getting some laughs. Yeah, because at that point in 1996, I had been writing financial reports for 7 years. Not a whole lot new there, okay? From 89 to 96, you're just writing financial reports. And as an engineer, you're not growing. You're just writing financial reports, and it's the same kind of report every day. So I got involved with Postgres because I felt that my career was not growing. I wasn't learning new things. I was just turning a crank, just putting out new reports. And I was super excited. I was working with a whole bunch of people throughout the world. One of my key people was in Siberia, actually, but I had people all over the world who were helping me. And I spent about 3 or 4 years as a volunteer working on Postgres. Just as a volunteer working, putting out releases, writing patches and collecting patches and so forth. And about 2000, I was asked to write a book. And then after I wrote a book, I was hired by a company in Virginia in the United States. Then I was hired by a company in Japan for 5 years. And I currently work for a company called EDB, and I've been with them for 18 years. So it's a very unusual job. Not a lot of people have the job that I have. My job is Postgres evangelist. So my job is really to bring the software to new people like yourselves and explain what it does. But probably the big shocker during that entire period is that this hobby or this curiosity that started in 1996, fast forward 28 years, and now Postgres is a dominant software in the industry. Almost every new company, almost every new startup who's starting a business is starting with Postgres. They're no longer starting with Oracle. Many of you may be using Oracle. They're nobody's starting with DB2 anymore. You might start with Microsoft SQL, but again, a lot of people still even don't do that. And there's really no other players out there. Yes, there are some niche players like Mongo and Elastic and so forth, but they're not relational systems. They're very specialized databases, and they're for specialized use cases. So what's very odd for me is that when you start something in 1996 as a hobby and you fast forward to today, you're now working on the dominant relational database in the world. And surprise, you don't start out that way. It doesn't, when you start, you don't think, oh, someday we're going to be the biggest database in the world. It doesn't happen. You don't think that. It just happens over time. But if you look at all of the big players, Amazon and AWS, Microsoft, IBM, Alibaba, pretty much everybody is standardized on Postgres. They all offer it on the cloud. All banks use it. All credit card companies use it. All IT companies use it. Retail, military, government. There really isn't a segment, I would say, that we don't have a major presence in. Any questions? Okay. So the question is why, right? Why? This I think gets into the meat of the problem. Why has Postgres effectively become this standard database for everybody? And there's really two reasons. And in the first 30 minutes, I'm going to talk about something called extendability. Okay. And then in the second reason, in the second half, we're going to talk about open source, the open source aspect of Postgres. is the other reason. So two reasons that Postgres is the dominant relational system. One is extendability. The second is the fact it's open source. Any questions? No. Nope. Okay, great. All right. So let's talk about extendability. We're going to talk about extendability, and then we're going to explain how extendability is used to handle today's workloads, particularly NoSQL. We'll talk about how extendability is used for data analytics, and finally, we'll talk about how extendability is used for something called foreign data wrappers. Again, these may be things that mean nothing to you. That's okay. We'll kind of go through them and give you an idea of what they do. But again, it's part of the larger picture of how something can go from a hobby to the dominant database in the world in a very short period of time, relatively. So Postgres actually started as an object relational database. Object relational means that it supports classes and it can be modified. Now that might not mean a lot, but I'm going to show you specifically exactly what that means. So, for example, this is actually I wanted to kind of give you a little history. Postgres actually started in the university. It started in the University of California, Berkeley, in California. Okay, it started 10 years before I started, so it started in 1986. So this software is 36 years old, right? Very unusual for software to live that long. Even more unusual for software to live that long and become the dominant database only 36 years later. So when it started at the University of California, that first 10 years, it was pretty much just used in academia. And then in the next 10 years, when I started, it was used by a small number of people. Then the next 12 years, it started to grow. And then probably the past 6 years, it's become a dominant player. So very unusual for software to go from academia and grow at that pace. Actually started by a man called Michael Stonebreaker, who had a vision of extendability. And that extendability ended up really being one of the two reasons that Postgres is dominant today. Let's talk about extendability. This is the Postgres system tables. If you're not familiar with the system tables, they record the structure of your database. So as you know, a relational system has a structure. You create tables, you create indexes, you create users, you create stored procedures, so forth. And those things are actually stored in the system. Actually, if you look at this URL here, this will actually show you, take you to the Postgres documentation. Okay. One thing I should have mentioned, this URL right here actually will take you to this presentation. So there's no reason, you don't have to make a copy. You can do it now if you want. Just go to this. There's a QR code right here. Unfortunately, it's behind the board here. I was kind of proud of that, but hey, it didn't make it today. But again, momjian.us is probably where you want to go. Not only is this presentation, there are 61 other presentations on that website. And there's over 120 videos of those presentations. So again, a lot of material. That's a lot of material. You know, it's kind of a high number, but if you've been doing this for as long as I have, 28 years, and you write 2 or 3 presentations a year, you get to 60 some at a certain point. I think it's 2,500 slides, just a huge amount of material. It's over 600 blog entries about our particular software. Again, all at this URL right here. Okay, I should have mentioned that earlier. I'm sorry. So again, the Postgres system tables. What made Postgres unique in extendability? Okay, if you take a look here, for example, this is where you define your table names. That's pretty standard. Here's where you define your column names for your tables. That's pretty standard. Okay, here's where your optimization statistics are. Pretty standard. But then you get into some things that don't look standard. For example, this table stores the data types in the system. And we start to understand what extendability is here, because up until Postgres, every time you had a database product, that product had a fixed number of data types. It had integer, character, date, maybe a Boolean, maybe a float, okay, for numeric values. But But what's interesting about Postgres is that we actually define the system, the data types in this table here, and you can add new data types to Postgres very easily. And that's what extendability is about, the idea that you can extend Postgres with new capabilities without recompiling, all right? Same thing over here. For example, the plus sign, the minus sign, the not equals, for example, these are what we call these operators. And normally, again, these are fixed. What the plus sign does is fixed. The minus sign is fixed. The star, the asterisk, it's fixed. In Postgres, you can define your own operators. You can make a new operator. You can question mark, period, or something ridiculous. Question mark star, let's call it that. And you can make it new, do something new. Over here, stored procedures. That's pretty standard. But Postgres supports over 12 stored procedure languages. Normally, relational systems have 1 or 2. We support over 12. Over here, aggregates, things like sum and maximum, max we call it, average. Normally, these are fixed, but in Postgres, you can add new aggregates. Again, over here, these are indexing methods. Normally, relational systems have indexing methods like btree and hash. We have a whole bunch of specific indexing methods that are not normally in a relational system. And you can add new ones if you want. So the reason I like this slide is it really shows you why Postgres is different than other systems. And later I'll show you why that's important. Okay. Let's take a look, for example, how do we add a new data type, which is something I talked about. We have an extension called ISN. It stands for International Serial Number, I think, or something like that. Oh, I'm sorry, International Standard Number. Yeah, International Standard Number. So when I run this command, as soon as I run that command create extension, I get 8 new data types that didn't exist before. What effectively has happened is I've added 8 rows to this table right here. And as soon as I do, I can now create columns using these new data types. And they probably have operators. They might have special indexing methods used for these. Very easy to add new capabilities. And again, we have the documentation for that. Let's take a look at a regular data type like integer, which every relational system has. And let's take a look at the new data type that I just added, ISBN. If I go into PSQL, which is our command line tool, and I say, show me these two, well, this one looks just like this one. It's got the same sort of description. These are different, but again, looks pretty normal. If I look at the PG type table, remember that yellow table? If I look at the integer one, I can see it looks pretty normal. In fact, I have to define how wide the field is. It's 4 bytes. These are my input-output functions and so forth. If I do the same thing for the ISBN, I can see the same thing. This is 8 bytes long, and I can even see here's my input-output functions. So the point is that when you add a new data type, it behaves just like an existing data type. And again, that flexibility is one of the things that has made Postgres so popular. Another thing, I know many of you are learning Python or have learned Python. We have a stored procedure language for Python. Normally, you would have this PL/PG/SQL, which is very similar to Oracle PL/SQL, and that comes standard in Postgres. Okay, but if you want to add a new one, you just create extension PL/Python-U, and all of a sudden you have a new stored procedure language. Okay, and again, this is the documentation for it. In fact, we support all of these stored procedure languages and more. This is a great web page right here, which outlines all of them. Why is this useful? Well, for example, if you're used to writing in Python, you can do your Python right in Postgres. You can do SPI, which is our C interface. You can do Perl. We can do Haskell, Java, Lua, Rust, PL/V8. PL/V8 is for JavaScript. So you can actually write stored procedures in JavaScript. Again, the idea is that Postgres has this flexibility, and this flexibility is what has made it so popular. I also mentioned the ability to add indexing methods. So again, most systems have B tree and hash. That's pretty standard. But we have a Brin index, which is designed for data warehouse. We have a GIN index, which is designed if you have a lot of duplicates in your indexes. We have a GIST, which is used for spatial search and general search, and even something called spatial partition GIST. Again, we have nice URLs about that. And if you think I'm making this up, if I actually query this system table, I can see that I have defined in the system tables B tree and hash, which are pretty standard for most relational systems. You can see Brin, you can see GIN, you can see GIST, you can see SP-GIST as well. Those are all part of Postgres, and we can add more if we desire. Okay. I talked about operators. Here's the plus sign. We've defined the plus sign here as taking an integer on two sides. And in fact, this is the function that it calls for PL for plus, and it takes two integers, and that's the way you define a plus sign. If you want to define your own operator, you can very easily do that in Postgres. You can define your own aggregates. You can define your own casts if you wish. You can also have external projects. We have a number of external projects that operate independently of Postgres. They're specially designed for use cases. For example, PL, PostGIS. How many of you heard of GIS? Oh, great. Yeah, I didn't know what it was when I started, but GIS is Geographical Information System. It's for doing maps and geographic locations, like how far are 2 points on a globe. You can make a map of an airport or a map of a city and then overlay it. So very sophisticated things you can do. Typically, you need a specialized database for that. But because Postgres is extendable, the PostGIS people over 20 years ago started working on this PostGIS, and it's very mature. It's been around for a long time. It has its own conferences, independent of Postgres. It's that GIS community is a completely different specialty. PLv8 I mentioned before as a server-side JavaScript. PG Vector has become very popular in the past couple of years for artificial intelligence. So if you're doing AI work in Postgres, you can do that. I actually have an AI talk on my website and a new one that I've written. The slides are not on my website yet, but I think I'm going to give it first in Montreal. So probably sometime in late January, you'll see it appear on my website. It's called Databases in the AI Trenches. So again, the slides will be. I'll post the slides on my blog once I release them. But again, really interesting what you can do in AI and Postgres. Again, typically you need a specialized database for this, but because Postgres is extendable, not a big problem. A lot of companies and projects have forked Postgres and created versions independent of our community. Here's a list of a bunch of them. Aurora is certainly well known. AlloyDB from Google. Informix actually has some Postgres code in it. Redshift, if you're familiar with that product. Vertica, Yugabyte, you might have heard of that. Cockroach as well is important. Greenplum is a data warehouse, again, built on Postgres. So kind of interesting. This is a list of some of the forks that have come off of Postgres over the years. So again, plugin's not a bad word. Plugin actually for Postgres is a natural thing because it was designed from the beginning to be extendable. It wasn't added on later. It's very hard to add on extendability. But because we had this from the beginning, it made it very easy. And again, you can use the built-in things, and you can also use the extendable things. Okay, this is kind of a key slide for me to kind of wrap up this section. People are kind of wondering, well, why is this extendability important, and why now? Why has it become much more important in recent years? Because when I started with Postgres in '96, extendability was considered to be useless. We had it, we didn't know what to do with it. It was annoying. It made Postgres slower. We talked about getting rid of it actually at one point. Because again, you're talking the late 90s. It's pretty standard. People mostly are doing order entry applications, right? Green screens, text terminals, and that's all you had in the late 90s. But in the early 2000s, the GIS community started to grow, and we started to see them use our extendability. We're like, okay, maybe it'll become useful. But what has happened in the past 8 years or 10 years is that the needs for relational databases have exploded. That's why we have so many different types of databases out there, like Mongo and Elastic and so forth. Because in the old days, all you really needed was character relational storage. And in later years, you started to have the need for data warehouse. But in the recent years, the need to store web browser data, particularly in JSON, the need to store mobile application data, which obviously would be needed for GIS, Internet of Things. AI is obviously a new thing. When we needed to have AI, all we needed to do was to use PG Vector. It had already been written. It was just sitting there. For years, I think nobody really knew what to do with it. Now we're like, oh, this is great. Let's use that, right? Document database is another thing that we decided was useful to be able to store things like chats and documents. GPS, GIS data, obviously important for GIS data. Social media, again, the requirements for relational systems have changed so much, and every other relational system, which particularly was proprietary, has never really changed. They try and add a little thing here and a little thing there, but because the foundation is not extendable, every time you add something like this, it always looks like a bolted on the side and just doesn't work the same, doesn't back up the same, transactions are different, indexing doesn't understand it, different parts of the system don't understand it, and that's a fatal flaw, and that's one of the reasons that when new people are starting workloads today, they're almost always starting with Postgres. I'm not saying people aren't using other databases. People are using MySQL all the time. They're using Oracle all the time. But why are they using it? They're using it because they have it already installed. They already have applications using it. They already have data in there, okay? But if nobody is using your platform anymore for new work, then effectively you are a legacy database, right? When I started in in the 90s, the big database, the big operating systems were, I'm sure many of you don't even know, Solaris, AIX, HPUX. Those were the big ones. Does anyone use those today? Probably not, right? That was it. What happened is Linux came in and offered an open source, better operating system that these other companies couldn't compete with. And what is happening today is the same thing. We're now offering an open source project, an open source opportunity that does things that proprietary databases can't do and almost no other database can do. And that is probably what has set us apart. Questions? Yes, sir. My wife raised her hand, but she was just yawning.
If you're talking about flexibility, give the user flexibility to make a monster. So the question is, how much money we can add without making control from the system?
Sure. Yeah. Hold on. So the question is, you have extendability, right? But if you use too much of it, it becomes complicated, and therefore you end up with a mess. Okay. This slide is the last slide on my website from a presentation called Non-Relational Postgres. It goes over JSON. It goes over full text search. It goes over GIS data. It goes over range types. It goes over arrays, just a whole bunch of things that Postgres does. And the reason I end this slide is basically to say, just every time you see it, you laugh. Don't overdo it, right? What happens as an application developer is there's certain cases where, I don't know if you've written a lot of applications, but there's certain cases where you can tell that you're using something for what it wasn't designed for. Where you start to store a JSON document as something that wasn't meant for it, you start to sort of, okay, if this is this, then this other column means something else. And that complexity, when you start to have to twist the system to make it do something it wasn't designed to do, that's when you start bringing in extendability, okay? But you're absolutely right. People can come in and they just say, I just want to use every extension and I want to store everything in JSON and I want to make everything searchable and full text search and let's add GIS here. And again, the problem is you may understand it, but none of your colleagues are going to understand it. So again, what we do recommend is not to go overboard, but you're going to know as you're going when you're going outside. And in fact, that's a great point because almost everybody who comes to Postgres because it's free, okay? Without a doubt. But what happens is when you come back to them 2 years later and you say, what value do you see in Postgres? The cost is not an issue for them. The cost savings is nice, but in fact, it's this extendability, it's this innovation, it's the quality of the software that actually makes them stay. So we have 2 to 3 conferences a month for Postgres around the world. I can only cover about 30 of them in a year. But the point is that nobody has a conference about saving money. They have a conference about technology that excites them. And again, this is the kind of thing, don't go overboard, but the flexibility, ultimately, using these extensions should allow your application to be simpler. It should allow it to be easier to understood and more efficient. And that's usually our goal. So it's a great question. Other questions? Yes, sir. So the question is, how do we integrate something like JSON into Postgres?
Not JSON. You are wanted like Python, Java, JavaScript. Yes, where you store the executables.
Okay, so the question is, if I'm doing a stored procedure language, where do I put Java? Where do I put Perl? Okay, Python. In fact, what we end up doing is we put the Python interpreter inside that process. So that process has its own Python, or its own Java, or its own JavaScript, or its own Perl. So we don't have a shared Python where all the executables use the same. We effectively start, when you call PL Python, we will start a Python in that process for you only. And then as you call more Python code, we'll reuse that process over and over again. But what we don't have is like a global, like a shared thing that we can, that's just way too complicated for us. Do we have external dependencies? You would have to have Python installed on the system to use PL Python, for example. Yes, yeah, good question. Yeah, you had a question.
Yeah, just to this question. Want to know, so I have a Python script. I put in my query to Postgres and it runs. Just that simple. Or I will define it on.
Yeah. So you basically say create function, and you put like quotes, and then you write your Python script. Pretty much that's it. And then we will take that, whatever's in the quotes, and we'll pass it to the Python interpreter. Python interpreter will interpret, it understands the column names and whatever, and then it'll execute and return whatever result you ask for. Yeah, same thing with JavaScript, same thing with Perl, same thing with yeah, so it's, you write your program as basically a text blob, and we just pass the text blob to the interpreter, and it gives us a result back. Pretty easy. Yes, over here. Yes.
I'm just curious, how are you writing code for like a legacy way or something?
So are you asking how we maintain the Postgres code? So we have a major release every year, and we have hundreds of people around the world who are working on the Postgres code 24 hours a day. So it isn't a small team, it's a big team. We have a ton of people from my company, EDB, a ton of people from Microsoft, a couple people at Amazon. Alibaba has some people, Fujitsu has some people, NTT has some people. We got some people from VMware and some of the European countries. We may have somebody from Armenia. I don't know. We have a bunch of guys in Russia. We have a bunch of guys in China. So everywhere, they're all working. The code uses Git, so it has a source code repository where we can all work together. And the code is always maintained. We're always cleaning things up. So if you look at the code today, I could pull it up if you want. It looks like a modern C program. It doesn't look 38 years old because we're in a company, they only clean up code if it makes them money. You're right. In most companies, you don't clean up code because you're always working on feature. In open source, people say this. I get an email, 2 or 3 emails a week, just saying that a comment has the wrong word in it, or it's spelled wrong, or it's this word should be different. It's not clear, right? So it's that level of detail, and you do that 24 hours a day for a year, and you do it for 28 years, and it's amazing how good that quality is. And again, that's why so many of those companies were using our source code because it's so easy to understand. Yeah, good question. Yes?
Are you using runtime code generation?
I'm sorry?
Are you using runtime code generation?
Are we using runtime code generation? We do LVM, which is it allows us to take the executor. So if you do a complicated query that has a complicated expression in it, we'll use a runtime interpreter to convert that to bytecode and run it in LVM. And that's really the only, I think, live runtime interpreter that I can think of for the Postgres code. I don't think there's another. That would probably be the only case where we use runtime. Yeah. Other questions? It's particularly useful for like a data warehouse, because data warehouse, you have very complicated expressions. You run it millions of times, converts to bytecode, and then you get better performance that way. Yeah, I'm sorry, yes.
There how to convert it to thread. I didn't compare and benchmark.
Sure. So the question is, can we convert Postgres to threads? We have researched it over the years. What we found is that normally when you start a backend process, that backend process is going to live for quite a long time. So the threads don't give us a lot of benefit. For example, when you're using threads for short-lived processes, like in a GUI, I want a thread to update this field, and I want a thread to update this field, that makes a lot of sense. But for Postgres, these sessions are very heavy. So the threads, the reason we haven't used threads up to this point is that it gives us good isolation because the processes are isolated from each other. If one process dies, we can allow that to die and the other processes continue. So the threads don't give us a whole lot of advantage. We have researched it, and we might eventually do it. I've seen some patches and talking about it, but the benefits are fairly minor for us. Yeah. Good question, though. Yes?
You have shown us points that contributed to the popularity of Postgres. What about the administration part of the database? Because for me, it's very easy to administrate, but of course there are hard parts in it. But for starting up your server or maybe all configurations, it's easy. What can you tell us about the part of administration and what work is being done to, let's say, maintain the easy part?
Sure. So for administering Postgres, one of the unusual things is typically when you buy a relational system from a proprietary vendor, they have one backup tool, one monitoring tool, one high availability tool, and so forth. With Postgres, because it's open source, we have multiple backup tools. We have multiple monitoring tools. We have multiple high availability tools. So what happens is you get a choice of all of these tools, and these tools sometimes become more or less popular over time. But the problem you might be relating to is that there isn't a tool to learn. You have to pick the tool you want to learn and then figure out how to use it. Now, my company, EDB, has sort of a full suite of tools. Percona, another company, has a full suite of tools. Amazon has their set of tools for their cloud. Google has their set of tools for their cloud. So effectively what you end up with is this very wide options of administration. And in fact, and then the bigger area is Kubernetes, because the problem effectively is that when you deploy Postgres, you typically need a backup solution with it, and a monitoring solution, and a high availability solution. And to deploy that is fairly complicated if you're doing it multiple times. And that's why a lot of people are deploying Postgres in Kubernetes, not because they need Kubernetes to like destroy and scale, but they need it to automate their deployments. So we're seeing a lot more of that to simplify the administration of Postgres. But there continue to be other options. There's Postgres Enterprise Manager for my company. I know, what's the name of the guys who make Toad? Who is that? The Toad, the Oracle tool. Why am I drawing a blank? Actually, hold on. I will pull it up on my handy website here. Here we go. Hold on. Here we go. Press. Here we go. Quest. Quest has a diagnostic tool for Postgres. Okay. So again, there's a whole bunch of vendors out there all producing all sorts of tools for Postgres, which is good because you have a bunch of raw offerings. But it is unfortunate because you don't have one tool. You got to pick the tool, right? And that is additional work that you have to do. I never figured out how to fix that problem, because we could create one tool, but then somebody else will come up with a new idea, and then that should be the new tool. So it's a very competitive marketplace, I would say. Yeah. Let me just finish with these slides, and then we'll get to more questions here. Yeah, I know, it's kind of funny. So again, this is the NoSQL piece. So for example, there are 4 types of NoSQL. Okay. Key value, document, columnar, and graph. Again, NoSQL is great for auto sharding, but not great for a lot of other things. This is kind of old. In a way, 5 years ago, people thought relational was dying and NoSQL was going to be the future. But what they realized was this: that there's a whole bunch of cool stuff you do with relational. And when you start to use non-relational, you lose all this. You lose the ability to look at the data in different ways, to integrate. And again, that's why I think Postgres gives you both. And again, another reason it continued to become very, very popular. Yeah, the problems they have reporting complex applications. Somebody asked about how do you put like JSON in a table. You just create a JSON B column and just put the data in there in JSON. And this is how you integrate a JSON check. Okay, so this is a key. This is a value. I want the person, okay, age 21, and it tells me that's the person, right? So again, very simple how you can do this. You can do DDL, data. You can modify the schema live on Postgres. This is actually one of the few cool things that we do. One of the cool things that we do. For data analytics, again, because we're extendable, we have improved this area over the past 28 years. Okay, I can probably put years on, I can say, okay, this one, remember this gentleman was asking about runtime code generation. This is probably done 9 years ago, 9 to 10 years ago. This is probably 12 years ago. This is 13, 14 years ago. This is 17 years, probably. This is 14 years. Again, you can see how every year we're making new, and for example, like I have a slide deck, a presentation about window functions on my website. I have a slide deck about common table expressions on my website. I have a whole bunch of blog entries about the optimizer. I have a presentation about data partitioning on my website. So again, really cool. I have a presentation about sharding on my website. So again, a lot of cool stuff. Because it's extendable, we were able to improve it incrementally, okay, pretty much every year. And now we have a very, very capable data analytics system. And normally the way we do it, because we have a very simple replication solution, is you can have a primary read-write machine, and you can just create a separate data warehouse machine and just do the analytics over there. Get all the live data. You don't have to copy it, right? It's live, but it doesn't slow down your primary system. You can have 5 of these, 10 of these, as many as you want, all right? Incredibly flexible. And let's suppose your data doesn't fit in Postgres. Let's suppose you have data somewhere else. You can use something called foreign data wrappers. You can connect to CouchDB, you can connect to Mongo, you can connect to Oracle, you can connect to Redis if you want, or MySQL. You can use JDBC or ODBC. You can, here's what it looks like. You basically create, you add an extension, right? Remember we saw that earlier? Yeah, we add an extension. And then we effectively create, this is all standard SQL. It's called SQL Med. SQL for, what does the Med stand for? Med, external, management of external data. Yeah, I always thought it was like medical. No, it's management of external data. And this is standard API for that. You create a server, you create a user mapping, and you create a foreign table. This table looks like it's in Postgres, but it's actually somewhere else. And you can query it just like it's local. Kind of cool. So again, you can have data in Postgres, you can go outside. So again, with Postgres, this is the first part. We're over time, but that's okay. Had a lot of great questions, and that's the most important thing. Object relational, we talked about it. NoSQL, we talked about it. Analytics, we talked about it. Foreign data, we talked about it. No other system does this. And I think that's why Postgres has become popular. Is just nobody can do this. And the proprietary group companies have basically given up. So there's Microsoft has 30 or more engineers working on Postgres all the time, even though they have Microsoft SQL, okay? IBM, very supportive of Postgres, even though they have DB2. There's an Oracle Postgres in the Oracle Cloud, right? I never thought I'd see an Oracle Postgres, but in fact, Oracle has given up, and they're saying, there are people who really love Postgres, we're going to put them in our cloud. So I applaud their humility in doing that. I would probably have no use for Oracle, but I'm glad they have a use for Postgres. And again, that is super exciting. Let me take questions, and then we're going to spend the rest of the time talking a little more about open source and maybe some other questions you have. Who has a question? Yes, sir.
So, if I remember, the latest release of Postgres was Cypher because of the security issue, right?
I'm sorry, say this again?
The latest release was also...
Yeah, had a security fix, huh?
Yeah, so are there any flow before the release to make sure that everything is okay? Or are there any...
Okay, so the question is that Postgres puts out a major release every year, and we have quarterly releases every quarter. And we support Postgres back for 5 years. So we're putting out 25 minor releases a year, and then 1 major release a year, effectively. In the October release, there was a security fix. Unfortunately, the security fix broke something else that we didn't understand, and we had to put out a fix for the fix a week later, which was super embarrassing, particularly because when we put out a security fix, we want people to install it right away because it fixes a security problem. And then when it has a bug in it, then we got to make them do it again a week later. It was unfortunate. We did research that. We do have a security team, which I am on, which does look at these things. The way the bug that we caused was very hard to predict. When we looked at it as a team, we're like, could we have anticipated? And we just couldn't. So I was disappointed because we told people to upgrade, and then we told people not to upgrade or wait, and I literally told the security group, I said, is anyone realizing that we're telling people to upgrade right away because of security, and then we're telling them not to upgrade, but we've already told everyone what the security problem is. And yeah, they said, yeah, we kind of, yeah. So it's not a great thing. Our security reputation is actually very good. If you look at the security releases for security specifications for Postgres, we surpass almost any other database. So I'm very proud of that, but we are fallible, and I am disappointed in the release that you're talking about. Other questions? Yes? I'll get you next. Yeah.
I was working to, I want to support
So the question is, do we want to support distributed transactions? We would like to support sharding, which allows us to push queries to shards. I don't see us going the gigabyte direction, particularly because it makes the system very complicated. And we're more of a general purpose database. So we applaud Gigabyte and what they're doing. Cockroach doing something else, right? A lot of people are doing cool stuff. I don't see that coming. I think our next target is sharding. It's not technically distributed transactions in the same way that Gigabyte does it. But maybe someday. Yes, sir.
Yeah, actually, my question related to the security itself. Is there any plans to have like transparent data encryption, calendar encryption, part of the Postgres? There are some solutions like Crepuna working.
Right. So the question is there any thought about doing security enhancements to Postgres, such as transparent data encryption, transparent column encryption? I worked, and my wife will remember, worked for a couple years on transparent data encryption. I got a proof of concept that I was working on. What we found was that it added, remember I talked about the complexity problem. What we started to realize that as we added this transparent data encryption, it was making Postgres more complicated than it needed to be. And because we already had storage encryption, we didn't know, the community debated whether transparent data encryption was enough of a value to make Postgres complicated. And we pretty much decided no. The good news is Percona is working on something. My company EDB has a proprietary transparent data encryption solution, and I think some other people are going to do it as well. So I'm disappointed. I thought it was important enough to do, but I'm not only one person, and I couldn't really.
Actually, not by customers also.
A lot of customers want it. The reason, the problem with that is effectively a lot of regulators want it, but the actual security value of the feature is smaller, and that's, I think, now transparent column encryption. We do have an employee at EDB called Peter Eisentraut. He's on the core team, lives in Germany. He is working on transparent column encryption, where the client would do the encryption. So that is actually being worked on. So we are very aware of the security requirements. I was disappointed about transparent data encryption. I don't know if we'll ever get it. I think transparent column encryption we're going to work on. Great. Let me just give me 2 minutes. I'm just going to pull up one slide, and then we'll take the rest of the questions, okay? Because I promised I was going to talk about open source. So let me just do that. Where was that one? Here we go. Yeah. Okay. No, is that it? Yeah, that's it. Okay. 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 I'm going to go with this one slide. This is a very big slide deck, but this is the way that proprietary development works. Okay, this is Oracle, this is Microsoft, this is IBM, this is every proprietary piece of code that doesn't develop in an open source way. You've got the developers, and you got your users. And the communication between these two only happens here when they release the code, and it happens here once they file a bug report, and it goes through sales, okay, to a product meeting, which eventually you only see when it gets down here, okay? The second reason Postgres is become so popular is that this is an incredibly inefficient system. Why can a group of volunteers like Postgres produce a database better than billion-dollar companies? not only better than billion-dollar companies, but the billion-dollar companies admit that we do better than they do, okay? And the reason is this. Open source, whether we're talking about Postgres, we're talking about Apache, we're talking about Kubernetes, we're talking about anything that's open source. This is the open source development. This is what development they use. Not like Mongo, not like Elastic, where they develop everything in a company and then release it out. This is an open source development model. In the development model, the users are involved in every step of the process. And because of that, the quality, the innovation cannot be matched by that previous method, okay? This is why open source dominates the enterprise tool chain. In the 90s, you used to buy editors, you used to buy compilers, you used to buy middleware, okay? You used to buy databases, you used to buy operating systems. Almost none of that happens anymore, to a very limited extent, right? So in that 20-some years, 25 years, you've seen this model creep up into the stack, where open source dominates almost all the tooling you're going to use in the enterprise. Okay, and I will take questions for the next 3 minutes until I run out of time. Who has the next question? Yes?
The point that for using Postgres, effectively you need
I'm sorry.
a very skilled team.
Okay, so that's a great question. So to run Postgres, do you need a very skilled team? The answer to that is yes. Postgres is more command line oriented, okay? It's much simpler to use than Oracle, okay? But it's probably harder to use than Microsoft SQL. Whereas Microsoft SQL is kind of GUI based and it's sort of integrated with the operating system. For Postgres, a lot of it's command line. Oracle's a beast, like it's just very complicated. So we're somewhere in the middle there. I think we basically have to, as a project, we have to balance flexibility, which typically makes something more complicated, with ease of use, which makes it simpler, simplicity, which makes it easier. So we're always trying to balance that graph. In fact, I have a blog entry about configuration parameters. We have about 200 configuration parameters. And what happens is every time we add a parameter, we have to decide, is there really a value to that parameter, right? And we're trying to make it so we have as few as possible, but we have to add some to make Postgres flexible. And it's that back and forth. I think people who come from other databases, they find Postgres is actually very easy to use, but it's a change. It's something different. And I think that difference is making it harder for them. But once you get used to it, you find that Postgres is much easier to deploy, much easier to use than almost any other relational system because it's so clear and sort of well designed. But you have to learn it, and if you're just coming fresh from another database, it's a big challenge, no question. Other questions? Yes?
Yeah, actually, I see a lot of activities from Performa, from Crunchy,
Yeah, Crunchy, another one, yeah.
Releasing open source tools.
It's Orlando, yeah.
But from ETB, from like this summit, I don't see movement or activities.
Okay. So the question is, you see Zalando, Crunchy, and Percona doing a lot of open source releases of software. And you don't see as many from EDB, and you're wondering why. That's some of that's true, some of it's not. So, for example, EDB is the primary developer behind the Kubernetes version of Postgres. So we realized as a company that most people need to deploy on Kubernetes. That automation for deploying hundreds of systems is just too hard. So we developed our own Kubernetes, which is using the modern tool chain in, I believe, Go and so forth. And then we donated it to the Cloud Native Foundation. So the Cloud Native Foundation actually is we have a huge number of developers working on the Cloud Native Foundation, improving that, and some other companies are actually helping us with that software as well. For example, Crunchy has a open source Kubernetes operator. Unfortunately, it's less. There are fewer features, and if you don't upgrade within 2 months, once it stops working because they remove the repository and then it kind of breaks. There was a blog entry if you're curious about it. So, and Percona is a completely open source company, right? And I've been to their conferences. My wife and I went last year to Denver to the Percona conference. So again, different companies are going to have different strategies in terms of, are we going to do everything in open source? Are we going to do none of it in open source? We're going to kind of meet in the middle. And every company kind of finds its different position of where it needs to be. So I do think, EDB was the biggest code contributor for Postgres 17, which came out. I think 31% of the code came from EDB, and the next number was, I believe, 18. Robert Haas did some analysis. So again, we are incredibly, maybe we're doing more contributing in the community, the database product itself, and maybe less in the tooling. Maybe that's what you're seeing. But we do contribute stuff. But you're right. Barman is another one, which is ours. But again, Crunchy has backrest, which is great, right? So we're like, PG Partman is from Crunchy too. So again, it's back to what you're thinking. Like everybody's out there doing their thing. Some of them are open source. A couple of them are proprietary. Like the Quest stuff, I think is all proprietary, right? So again, you have a whole spectrum of stuff that you can choose from. And I think I am unfortunately out of time. Yep. So I know maybe that wasn't exactly what you expected, but what I do love is that we had a chance to answer a lot of your questions. They were all really good questions. I'll be here for a while if you have anything that you haven't had a chance to ask. But thank you very much. Hopefully, Emma is our host. Hopefully, we'll be able to do this again with as soon as it's available. But it's been wonderful to be able to speak to you. Well, yes, thank you. We will be back in June. So June, July. So yeah. So we would love to maybe do this kind of something again.
More information